In the last class, we have discussed what is the partial derivatives of w if w is defined as f of x, y, z, and each x, y, z is a each of these functions is a function of uh, r and s. Say g of r and s, and this is h of r comma s, and this is k of r comma s. Okay. If this is the case, then we have defined the derivative, total derivative, the partial derivative of this w with respect to partial derivative of w with respect to r is defined as partial derivative of f with respect to x, then multiply it with the partial derivative of x with respect to r, then partial derivative of f with respect to y, multiply it with partial derivative of y with respect to r, then partial derivative of f with respect to z times partial derivative of z with respect to r. If this function w contains only two variables, if this z is absent, then this term will be absent in the formula of partial derivative of w with respect to r. So that is given in this area where w is equal to f of x, y, and it contains only two independent variables, x and y, and x is a function of r and s, and y is a function of again r and s. Then this contains the partial derivative of w with respect to r contains only these two terms. Okay. If the another case is if this w contains this is the case where we have discussed here w is equal to f of x, y, and x equal to g of r comma s, and y is equal to h of r comma s. In this case, we define partial derivative of w with respect to r as partial derivative of f with respect to x times x with respect to r plus partial derivative of f with respect to y and y with respect to r. Okay, this is the only possible terms for this formula. Similarly, you can define the partial derivative of w with respect to s by replacing this r by s. Now, if this is the case, w is equal to f of x, and this x is, it contains only one variable, and this x is again a function of g comma s, g of r comma s. Then we define the derivative of w. Yeah, ultimately, this w is a function of r comma s again, because this is f of x of r, x is equal to g of r comma s, then this is g of r comma s. Then we cannot define the total derivative, we define the partial derivative of w with respect to r again. So it contains only one term rather than two terms. The partial derivative of f with respect to x contains only one x, then x with respect to r. Similarly, you can define partial derivative of w with respect to s using this formula, partial derivative of f with respect to x, because it contains only one x, then partial derivative of x with respect to s. Okay, so this is the formula for the partial derivatives w if w contains only one independent variable x. So we can this example 4 illustrate the case where f contains x and y. So w is equal to x square plus y square, and x and y are defined in this manner. Then partial derivative of w with respect to r. So already discussed in the case where x, y, z are there. This is only two terms, partial derivative of w with respect to x, that is the derivative of this with respect to x, that is 2x, and partial derivative of x with respect to r by taking s as a constant. So that is 1 here plus 2 times y times 1. So this is from partial derivative of w with respect to y and derivative of y with respect to r. So this will give 2r. By multiplying and adding, we can get partial derivative of w with respect to r is 4. Similarly, you can define partial derivative of w with respect to s. Okay, so these are the formula for partial derivatives of or derivatives of a function which contains more than one independent variables, and each of these variables is again a function of one or more variables. Okay, now we will discuss the implicit function. In each of these cases we have discussed here, in each of these cases w is explicitly given in terms of x and y, and x is explicitly given in terms of r and s. But in the next case we will discuss the function, the derivative functions for which this f, if f is the function and f is a function of xy, but this is not explicitly given. Okay, so if f of x, this function is defined as as in the implicit form, that is f of xy equal to 0. From this, how will you find the derivatives? That is the next idea. If this x and y, f of xy equal to 0 is the usual case, we consider this as a y is equal to some h of x, but we are not given this is this explicitly, but we are given some formula or some equation f of xy equal to 0. Say in the usual case we have discussed x square plus x cube y cube, uh, this is a y cube plus 3xy equal to 0. So from this you can find dy by dx, okay, by differentiating this equation. From the right side we can get 0 and left side 2x plus 3y dy by dx, 3y square dy by dx plus by using product rule 3 times x dy by dx plus y times the derivative of x. Using this equation, from this you can extract this dy by dx, then you can explicitly write what is dy by dx here. So the similar can be done in the case of partial derivatives. For that we assume w is a function of x and y, but that is given by some equation, f of xy is equal to 0, and then how will you find the derivative of this? Okay, so this is the usual way of finding the derivative. Okay, this is what we have discussed. 0 equal to partial derivative of dw by dx, that is equal to partial derivative of the usual way is finding this this f of xy equal to 0. We write what is dw by dx. Dw by dx, if this is w, we can say that this is also 0. Okay, then how will you find this derivative? This is partial derivative of f with respect to x, then multiply it with derivative of x, plus partial derivative of f with respect to y, then derivative y with respect to x, in order to find dw by dx. In fact, this w is a function of x and y. Okay, so you can consider this w is a function of from this equation you can this is not the x and y are not the independent variables, but one variable can be expressed in terms of other. Okay, so that means y is equal to from this you can write y is a function of x. Okay, y can be a set of x from this equation. Okay, so that's why we write dw by dx. Okay, how will you find the derivative of x with respect to this expression? That is dw by dx is obtained from this. So from this you can write 0 equal to I just keep that dw by dx, that is 0 is equal to, from this you can write this as fx, the derivative of this expression with respect to x, then dx by dx, that is 1, plus this is fy and dy by dx. Okay, from this expression you can find the value of dy by dx. Okay, you can extract that value as minus fx by fy. So this is the usual way of finding dy by dx using implicit form. Okay, this I have discussed just now. Now how will you this is the use of partial derivative with this partial derivative to evaluate the total derivative. Okay, so now this is the formula for implicit function. This is what we have discussed. So this is an application for partial derivative. So in case of finding the derivative of total derivative of y with respect to x, okay, that can be obtained using these partial derivatives. Okay, that is by using this formula dy by dx equal to minus fx by minus fy. So this minus fx is nothing but minus partial derivative of f with respect to x divided by partial derivative of f with respect to y. So this is the formula for implicit derivative. This is the illustrative example for that. Find dy by dx using this. For that we use dy by dx equal to minus the partial derivative of this expression with respect to x first. That is the partial derivative of x with respect to f with respect to x is for this term there is no x, then we are considering y as constant by taking partial derivative of f with respect to x. Then this is 0, then this will give minus 2x, and derivative of this with respect to x, okay, by taking y as a constant. So that will be minus sin, the derivative of sin xy is cos xy into derivative of xy. Derivative of xy is y, okay, because y is a constant here. So from this you can evaluate partial derivative of f with respect to y. That will be this one. So this is the dy by dx using the partial derivative. So the same partial derivatives of this expression f of xy, the expression f of xy can be used to evaluate the total derivative as well. So this completes section 14.4. So please try to work out the exercise problems and come up with your doubts. We will arrange a Google Meet for discussing that. Thank you.